like to welcome everybody to our strategic farming program today. And the topic today is cover crops, addressing key questions, challenges, and opportunities. And just like to remind everybody that these sessions are brought to you by U of M Extension and generous support from the Minnesota Soybean Research and Promotion Council and the Minnesota Corn Research and Promotion Council. I'm Liz Stallman, a regional extension educator in crops out of the Worthington Regional Office. And today we have joining us our speakers. We have Jeff Vetsch. He's a researcher at the Southern Research and Outreach Center in Waseca. And then Dr. Axel Garcia y Garcia. He's a cropping systems specialist at the Southwest Research and Outreach Center in Lamberton. So with that, I'm going to turn it over to our first speaker today. Jeff, I'll turn it over to you.
Thanks, Liz. So this is a study that I started back in 2021 to look at cover crops, nitrogen rates, and cropping systems and their effect on nitrogen loss in tile drainage water, corn production, and soil health. And I'm working on this project with Dr. Anna Cates. Today, I'm going to kind of focus on the water quality aspects of this, on the cover crops effects on water quality. Prior to this study that I'm going to talk about in a moment, I conducted a study in the same research site here in Waseca from 2017 through 2020. And what we found in that project was that years when we got some decent cover crop growth, and this is not great, we're looking at 200 to 250 pounds of dry matter per acre. We saw a nice reduction with cereal rye in nitrate concentrations in tile water. But too many of the years in this corn-soybean rotation, we just did not get good growth. And part of that was we were trying to overseed cereal rye and a blend of annuals that would winter terminate. We were trying to overseed them in this corn-soybean rotation with full-season hybrids and varieties. And you just very struggled to get good establishment. Sometimes it's too dry, sometimes it's too wet. And one of the things that I realized after this study is it kind of aligned with work that was done by Strock and others at Lamberton, that there's no guarantees that you're going to get good establishment, and maybe 1 out of 3 or 1 out of 4 years is typical. And that's probably not going to move the needle very much for water quality or for soil health. So I think if we know cover crops are a major component of nutrient reduction strategies, both in Minnesota and across the Midwest, but maybe what our priority should be is to place them in production systems where they're likely to thrive and not only improve water quality or reduce nitrate concentrations in tile drainage, but also have benefits for soil health and sustainability. So clearly, crop systems that are short season crops like peas, sweet corn, small grains, and corn silage are kind of no-brainers, where cover crop establishment and having them in those systems is kind of ideal and they should do well. Of the 8.6 million acres of corn planted in Minnesota in 2023, about 350,000 were harvested for silage. And that's not a lot, but when you add the acres of peas, the acres of sweet corn, and small grains in Minnesota, you get near the 2 million acres total. So these are acres that certainly need cover crops and are kind of the low-hanging fruit. The treatments in this study, there were 9 that had tile water monitoring, 2 cropping systems, corn grown for grain, corn grown for silage, and the corn grown for grain did not have a cover crop established. This was in continuous corn, but the corn silage treatments had cover crops. There were either no cover crop, a cereal rye cover crop that was terminated in the spring with herbicide, or an annual blend that terminated in the fall, late fall, with cold temperatures. And that annual blend consisted of oat, forage peas, and radish. And the cereal rye and the oat, forage pea, and radish seeding rates are there at the bottom of the screen. Nitrogen rates, we had a control that got 4.6 pounds of N from starter fertilizer. And then the total N rate in the other treatments was either 180 or 220 pounds of N per acre for corn on corn. And the timing of that was 20 pounds was applied at planting and the rest as an early side dress. So kind of a chronology of this study. We take our up here in the upper left, we take our cover crop yields. We're usually around the 7th to the 10th of September. We clean off that plot or had a local farmer do that for us. Then we try to seed those cover crops. We did that with a no-till drill. We try to do that as soon as possible after the silage harvest is conducted. In about 6 weeks, you see this lower left picture. That was kind of the amount of growth that we got in that fall. This is the oats. You see the oats growing there, the radish, and the forage peas over here. Then in November, early in November, we do strip tillage in this system. And on these poorly drained, heavier clay loam soils, that is kind of necessary to grow corn on corn, especially in the corn for grain system, but probably not necessary in the corn for silage system. But we wanted to maintain that the same. At this time in the early fall or late fall, early November, we also applied our phosphorus, potassium, and sulfur fertilizers, but no nitrogen. Then about 2 to 3 weeks after that, this is kind of what like the field would look like. This picture here in the center middle that's labeled November 22nd. This is our oats, radish, and pea, and you can see that the cover crop now has frozen out and died, and that the strip till berms are next to it. And by springtime, it's hard to find this residue. In fact, a lot of it kind of blows away. So that doesn't provide a tremendous amount of cover in the fall, but it does not provide very minimal cover in the springtime. Compare that to the photo at the upper right. That is our cereal rye that's allowed to grow through the spring. You can see the strip till passes through the middle of it. We then plant, or we burn down that rye, we plant, and then we side dress N. We take cover crop biomass samples both in the fall, usually around the end of October, and then again in the spring from the cereal rye, usually right before the burn down, which occurs around the 20th to the 25th of April, with a targeted first week of May planting date. The biomass cover crop yields we received, or the amount of biomass, is shown here in a table. The first fall we had decent growth, not outstanding, I'd say average, almost 300 pounds of dry biomass in the cereal rye that fall, and about 250 in the annual blend. The next spring, you see there's really no change in the cereal rye. The cereal rye grew, but part of that no change in biomass is the fact that the strip till does remove some of the stand. So even though the cereal rye biomass had probably grown 5 to 6 inches by the time we took it in the spring, the amount of biomass was similar. The fall of 2022 was a very dry year. We could not get much establishment. In the spring, we did get some measurement of growth. There was a little patch of cereal rye here or there, but it was virtually nothing. The fall of 2023 was also dry, but we had better establishment. It turned out better in the annual blend than in the cereal rye. But then by the spring of 2024 was a really good year for the cover crop growth, and the cereal rye went from 92 pounds of biomass in the fall of 23 to up to 676 by spring. The fall of 24 didn't get a lot of growth, but by springtime we were up over 500 pounds. But part of that was the fact that this note at the bottom, we did not do fall strip till in the fall of 2024 because the soil conditions were just not ideal. Earlier or mid-October, it was too dry, and then the end of October, it started raining, and it's just stayed wet all the way through mid-November, so we decided to wait, and we did that strip tillage one day before planting in the spring of 2025. And the fall of 2025, we had pretty good cover crop growth. So what are the impacts of these cover crop and nitrogen rate treatments on nitrate concentrations in tile drainage water? This is the thing that we really want to study in this project. Is we'd like to see a reduction with that cereal rye and possibly with the annual blend in nitrate concentrations to help mitigate some of that N that's lost to the environment and ends up in the Gulf of Mexico. In the 2022 year, the nitrate concentrations were least in that silage corn with the cereal rye, 5.7 milligrams per liter, which is actually quite low value for tile drainage water in southern Minnesota. They were greatest with the silage corn with no cover crop, 9.4 milligrams per liter, and intermediate with the grain corn, no cover, and the silage corn annual blend. And these values are averaged across nitrogen rates. 2023 was the year when we did not get very good growth in the fall and almost no growth at all in the spring. And you see there was no difference in nitrate concentrations between the silage systems, the no cover crop, the cereal rye, and the annual blend. And that makes sense. If you don't get good growth, you're not going to mitigate any nitrate losses. That cover crop is not going to take up any of that excess nitrogen. But the grain corn system with no cover crop actually had significantly lower nitrate concentrations than the silage system. And that does make sense, and we'll talk a bit more about that a little bit later. 2024 was a year when we had extremely heavy tile flow. Over 20 inches of drainage we recorded in that year, as we had 20 inches of precipitation in the month of May and June alone. Because of that, you see nitrate concentrations in the tile drainage were much higher. We flushed out a lot of nitrate, especially in the spring in those months of May and June. The silage corn with no cover and the silage corn with the annual blend were the same. The annual blend just did not provide any mitigating factor because it terminates in the fall. But the silage corn with the cereal rye had a reduced nitrate concentration, but not quite as low as the corn grain numerically, but statistically they were similar. In 2025, we had good growth in the spring, but not a lot of growth in the fall. But much of our tile drainage was actually in the summer. We had a very wet June, July, and August. So the impact of the cover crops was less because more of the drainage fell in the summertime than in the spring. But still, the cereal rye was less than the silage corn with annual blend, but statistically similar to the silage corn with no cover crop. And again, the grain corn with no cover had the lowest nitrate concentrations. The flow adjusted nitrate losses on the right, I won't go through that line by line, but basically that is the pounds of nitrogen that are lost per inch of drainage. And our drainage amounts or volumes amount or mass of drainage range from about 7.5 inches in 2022 up to 20 inches in 2024. So if you take those numbers and multiply them by 20 inches of drainage, you get an idea of how much N was lost in that 2024 system. Down at the bottom here, we had the nitrogen rates averaged across the crop systems. And you see that always the 220 pound N rate was always greater than the 180, and that's very consistent. And that agrees with literature. Whenever we put on more nitrogen rate, the concentration is almost a little bit always greater. It doesn't tell the whole story for 2024, just looking at the means or the averages for the year. This has the 9 treatments that we monitor, and it has them over from April through July of 2024. And down here at the bottom is the control that only gets 4.6 pounds of N, and you can see that that has very low nitrate concentrations. Here in April, the green is the silage with rye, the yellow is the grain corn, green for green rye and yellow for yellow corn. In April, they were fairly similar across the two N rates, where the higher N rate has the open symbol and the lower N rate has the filled or the blackened in symbol. Then when we go up to the colors above, the beige color is the silage corn with no cover. The blue is the silage corn with the annual blend. You see that those were similar too in April, but in May, a lot of that changed. The cereal rye concentrations of nitrate increased compared to the grain corn, and the no cover increased compared to the blend. Then in June, the cover crop treatments, the cereal rye stayed about the same, but the blend decreased, as did the annual or the silage corn with no cover, and the grain corn came down just a little bit. And you see what happens in July. So if you think about this, there's kind of 4 bullet points to the right. One is that the 220 pound rate is always greater than the 180. The other is that the grain corn is approximately equal to the silage corn with rye in April, but not in June and July. And the silage corn is approximately equal to the silage corn with the annual blend in April and June. But where did all this N come from here in May, and why did that spike up, and did those concentrations increase so much? Remember that only 20 pounds of N were applied at planting, and the remainder of the nitrogen fertilizer was side dressed in early June. So all this N that you see in May is all coming from the soil, and that is where this becomes challenging. These highly productive clay loam, high soil organic matter soils can hold a lot of nitrogen and mineralize a lot of nitrogen. And you get a wet spring, and the cover crop has been terminated, and a lot of that N can be released, and was in this scenario in this year. So this just highlights some summaries. Years when we had good cover crop growth in the fall or in the spring, generally we had a nice nitrate reduction. The 180 pound N rate, I didn't show this data, but that optimized silage yields. But the corn grain system required 220 or 260 pounds of N per acre, and that was kind of one of our hypotheses. So we can probably get by with less N in a corn silage system. Nitrate concentrations in tile drainage were 39% less with the rye than with the silage with no cover in 2022, and 30% less in 2024, and 13% less in 2025. The only year the blend reduced nitrate concentrations was that first year, 2022. So that fall terminated covers are probably not going to do much for water quality, and probably not do a lot for soil health either, because they only really survive maybe 2 months at the most, but probably 4 to 6 weeks. Nitrate concentrations were about 20% greater with the 220 pound rate compared to the 180 when averaged across all the cropping systems. And nitrate concentrations were less with the corn grain system in 3 of these 4 years than with the silage system. But that might be related to the fact, or probably clearly is related to the fact, that we just need less fertilizer N in the silage system than we need in the corn grain system. If you're not super comfortable or understand the ideas behind the nitrogen cycle, you're probably wondering, why do we need less N in corn silage? Well, it's because we've taken away all the biomass, and that biomass results in what's called N immobilization, and it also keeps the soil much cooler because of all the residue. So when you do that, you can actually get by with less N because more N will come from the soil. With that, I'd just like to recognize the funding source for this study. It was AFREC, or the Ag Fertilizer Research and Education Council, that fertilizer checkoff, the 40 cents you pay per ton of fertilizer, and the University of Minnesota Ag Experiment Station, and recognize my co-author, Dr. Anna Cates, and Kyle Holling, who's our researcher here and does the daily drainage research monitoring of this facility. That's what I got, Liz. And if we want to take questions now, or we can leave them for later, and I'll stop sharing my screen.
Okay, thanks, Jeff. Yeah, and Jeff, and I know, and for our audience today too, I know you've done a lot of work on the fertility end with cover crops. So if people have some questions about that too, be thinking about that. We do have one question that we have some questions here, but one that relates to your presentation here. Basically, it looked like your annual blend of covers resulted in a similar amount of nitrate loss in the tile water as no cover. So you might have kind of answered this already, but yeah, how much of a benefit are we getting from these sorts of winter kill covers from a soil health, hanging on to soil standpoint? If the residue just blows away in the wind, is it worth it to spend the money?
Yeah, I think they answered their own question. And I think after silage, those type of covers, because silage is, you're probably not going to establish them until mid-September. After silage harvest, those annual terminated covers are not the right option. But if you're looking at something like peas or sweet corn, where you're going to terminate much earlier and you're going to be able to establish earlier, you're probably going to develop a lot more biomass, and that could protect the soil at least through the late fall, but probably not in the early spring. And the person who wrote the question is correct. It doesn't appear that these annual terminated covers are going to do much for water quality, and likely not much for soil erosion after they freeze and desiccate. Correct.
Well, and related to that too, before I turn it over to Axel, I was just curious because you didn't really have a tremendous amount of biomass even in the overwintering covers. When were you terminating those? Were they terminated pretty early in the season?
Yeah, that's a good question, Liz. So we were terminating usually around the 20th to the 25th of April, but some years we left them go till the very end of April, because because of wet conditions and just not being able to get in there to terminate the cereal rye, or we were anticipating a little bit later planting date. But we wanted to get them terminated at least 7 to 10 days before planting corn, and we were targeting our corn planting before May 10th. Now recognize that with corn silage in a cropping system where farmers are planting, maybe a half to a third of their acres or more to corn silage, they could probably plant those acres a lot later because corn silage could easily be harvested and planted up until probably Memorial Day. So if they wanted to, they could delay that termination of that crop or harvest it if they want to. And that is done in southeast Minnesota regularly, where they'll actually harvest the cereal rye off the field in late May and then immediately plant their corn for silage again. So it
Yeah,
depends upon their crop system and how soon they want to plant.
and you gotta, yeah, it would be interesting to see if it was terminated later, what that would be. But let's see.
And the other thing I would mention, Liz, or remind them about is that we did do fall strip till. So that does remove some of the stand. If we didn't do fall strip till like in that 2024 fall going into 2025, we had a lot more biomass because we didn't. The strip tillage does, I would say, eliminates a third at least of the stand.
Okay, valid point. One more that's kind of related to this presentation before I turn over to you, Axel. Does the need for less nitrogen in silage corn have something to do with the fact that the silage corn is taken off before the corn grows to full maturity?
Yeah, that is part of it. But the real factor, I think, is just the fact that you're taking all this carbon and this biomass away from the field. So you're minimizing the potential for mobilization of nitrogen in the soil the next year. And you're blackening the soil. And these heavy clay, poorly drained soils, taking all that residue away and having a black, relatively bare soil in the next spring is going to impact the amount of nitrogen that's going to be mineralized and minimize the amount that's going to be immobilized. Now, clearly, you're not taking away the root biomass below the ground. That's still there. But when you remove that much above ground biomass, that affects the nitrogen cycle tremendously.
All right. Okay. Well, thank you, Jeff. And again, if we have any more questions, but we'll turn it over next to Axel. And Axel, I know you've done a lot of work looking at how to, best get, the most growth out of cover crops and establishment. You also looked at nitrogen relationships, water quality, all kinds of things, but we'll turn it over to you.
Thank you.
Yep.
Okay. Well, thank you very much, Liz. Just to start with, I couldn't agree more with Jeff's talk. Provided the way the experiment he showed has been conducted. Terminating cover crops very early in the season, it translates into really very low biomass too. And obviously, if we have low biomass, it means that the benefits that we are expecting from the cover crops are going to be minimized or reduced. But that's the way it works if we want to keep our way to produce corn and soybeans in the state, which is the best way to do it regarding yield production. So that said, yeah, I really appreciate the invitation to be part of this webinar with Jeff. It's been fun last year, and I hope we can translate this into something that is going to be useful for our listeners. As Chief Liz said, I am Axel Garcia y Garcia from Agronomy and Plant Genetics. I am located in Lamberton. I do a lot of work. I've been doing a lot of work along with Liz regarding cover crops into corn and soybeans, doing probably close to 10 years so far. And we've tried a lot of things. And we've been sometimes happy, sometimes frustrated, those kind of things. But overall, from my own perspective, cover crops work within the corn soybean rotation only if we make some necessary changes to the way we produce. I'm not saying with that we should do it that way, but I am saying that if we want the cover crops to work, in other words, to produce more biomass, we have to change a little bit some of the things we do. One of the major keys to cover crop success in the state, at least, is selecting the species. Obviously, we can have a simple or a mix of species that fits what we are trying to accomplish in the reality of our cropping system work, but that is not really very evident. In Minnesota, in the corn soybean rotation, basically, we try to work as much as we can with winter cereal rye. And the reason for that is because it's really a tough crop. It overwinters under our conditions. And it most of the time, since I've been doing it, it comes up pretty well in the next spring. Then we have also tried some other cover crop type, like winter oilseed crops, and probably we'll talk a little bit more later. But at the end, we need a cover crop that will work within what we are doing. That's the message. So for today, I just wanted to highlight this LCCMR trial that we started a year or so ago. We are doing it in 3 locations. It's going to be done by the end of next year. We are doing it in Lumberton, Waseca, and Grand Rapids. Let's say it's quite simple in its design. We have 6 seeding rates of cereal rye. Which are, these ones are here, 0, 30, 50, 75, 100, and 35 pounds per acre. And we have 3 termination dates, which are 10 days before planting, at planting, and 10 days after planting, which is basically the last one is planting green. Soybeans, okay, was our next crop in this experiment in all 3 locations is soybean. And then we have several measurements, such as biomass, green cover. We are estimating water use of both crops and obviously crop yield. So I showed this last year and I wanted to show again. So this is basically the biomass of our cover crops at the 3 locations. And these are an approximate of the seeding rate because of just the way we produce these graphs. But basically what these graphs are telling us is that one, depend on when we terminate, that's going to be make a huge difference on how much biomass we produce. For example, the earliest termination for Grand Rapids, which is this gray line here, was around May. But remember that Grand Rapids is quite colder than the south of the state. So we produce really very, very low biomass. Probably close to what Jeff was showing. So similarly to Waseca, where Jeff is located, our early termination was May 5th, which is already around 1,000 pounds per acre, as compared to, I wrote it down somewhere here, Jeff was terminating between the 22 and the 30th of April. So it makes a huge difference when we terminate the cover crop. And by the way, this cover crop were planted around the 20th of September of the previous fall. So within a location, which is how we should look at this, we can see that the later we terminate it, the better it's going to be. So if we in Grand Rapids, if we terminate late, the biomass production it spikes to around less than 3,000, let's say, pounds per acre. A little bit more for Lumberton, and in Waseca goes to close to 4,000. Okay, but this late termination means around the 20th of May. So that it also means that we will be planting the next cash crop pretty late. In our case, what we did was we interseeded soybeans, okay? So that's one thing that these graphs are telling us. The other thing that these graphs are telling us is that within a termination, there is not much difference in terms of the biomass that is produced by different seeding rates. So what I'm trying to say is that it doesn't matter for the earliest termination, it doesn't matter if I apply 30 or I apply 135 pounds per acre. It repeats for mid-termination, and it repeats for late termination, and it repeats for each one of the 3 locations. This is an important thing, because if we are going to be planting cover crops, maybe we don't have to put too much seed on the ground, okay? So this is the first year results. We are working on the second year already, and then we are going to have a third one. So this is and this repeats for the other 2 locations as well, within each one of the termination timing. So there is no statistical difference on the biomass that is produced by different seeding rates. So, and this is for each, the soybean yield as affected by the cover crops and the termination timing at each location. So basically, if you see here, the pinky color is 10 days before planting. We terminated 10 days before. and then we planted. And this, the green, we terminated and planted. And the blue, we planted soybeans and then we terminated 10 days later. So it's planting green, basically. So if we look at the Grand Rapids, for example, you can see that there is almost no difference across all these combinations we have here. There is a slight difference when the seeding rate is a little bit higher, but the significance is very slim. There's not much difference. If we go to Lamberton again, very similar all across. Basically here, there is no difference across the different treatments. And if we go to Waseca, the same thing. So I guess the take-home message here is that if we plant green first, so it looks like there is no significant difference, but I have to agree that the differences are very high. So we have to have a second look at this one. And the second thing is that within a location, in this case, either Grand Rapids, Lamberton, or Waseca, there is a time-depending, or let's say weather-depending thing here. The environmental conditions affect a lot what we did. But this is just as a preamble of what we are going to be talking about. Then this is the termination window for all three locations. It looks more or less like this. We combine all three locations, and you see that, as I said previously, within a termination timing, it looks like seeding rate does not affect the biomass that is produced for each one of the three locations. So with that, I am done. I would like to acknowledge our funding institution, which is the LCCMR, the Environmental and Natural Resources Trust Fund, through the LCCMR. We've got some help in previous years from the Minnesota Corn, and obviously all our colleagues who have been supporting us with our work at all three locations. With that, I pass to Liz, and thank you very much for your attention.
All right. Well, thank you, Axel. And thanks, Jeff. And yeah, we do have a number of questions here that I think will pertain to you guys. But I think just a driving point with all this, I think both of you would agree with us too. I mean, we get the most benefits from our cover crop when we can get more biomass, right? So what can we do and how to make that fit into our system without affecting crop yield too much? And yeah, it would be interesting, just off the top of my head, Jeff, have you done work like looking at nitrate losses when there's been more biomass too? And again, that's really hard to do in a corn, continuous corn system, just because we got to plant corn earlier, or if you try planting green with corn, we know that we've seen yield hits with that. So again, just trying to protect yield, but get these benefits too.
Yeah, I would have to probably refer to research that's been done in Iowa and in Illinois and Purdue, where they'll get like Axel said, they can get 2,000 to 3,000 pounds of biomass and easily over 1,000 to 1,500. And they've seen as large as a 60% reduction in nitrate concentration, or reduction in tile drainage water when they get that kind of biomass. But I would say that that value in that 40% is probably more typical and is probably more of a target for our location or in our area. Mm-hmm. I think one thing that I was writing some notes as we were talking, and I think that an interesting point would be to evaluate or to study just the use of strip tillage and how you'd manage that in a system with cover crops. If you do fall strip till, and it's aggressive enough, maybe you could actually plant corn green or terminate right at planting, because you always have that strip till zone that basically doesn't have a cover crop really close to the plant. And that would not provide that green bridge, and it would not provide that competition and allelopathy because of the strip tillage. If you change that to spring strip till, which probably would not be a good idea on our clay loam soils, but could be done in the southeast Minnesota on lush soils or on loam soils, then maybe you're obviously going to get way more biomass if you went with spring strip till instead of fall. But the strip till tillage system is just it works so well with cover crops and in this no-till system. You clearly can plant no-till if you want to, but on our poorly drained clay soils, it's going to be a challenge. It can be challenging.
Yeah, and that question around the biomass kind of ties with some of our questions we've gotten here, like what amount of biomass is sufficient? I know from a weed control standpoint, we've talked about trying to get target like, well, at 2,000, we can see some benefit, 2,000 pounds per acre, but up to 4,500, that's where we really start to see more of an impact. But that's very challenging to get. I don't know if either of you have some more comments to share on that too, about biomass for other types of benefits. And also that ties with the question, is it possible to have too much biomass?
Yeah, I can jump there if you want. But first,
Okay.
if I have time, I would like to comment a little bit on the previous questions
Oh, sure.
to Jeff. Yeah, I've done as well nitrogen studies with cover crops in corn and soybeans. And one of the issues as well is that results are so variable. This is inherent of the soils. I mean, if you take a sample just here, 3 feet farther from there, your results are going to be probably very, very variable. It can be very high or very low. So, and that puts just one more, level of complexity into this thing. But the real thing is, like, if we just forget the numbers, let's say, if we put a cover crop on the field, and that cover crop is going to grow a little bit, it did grow because light and several things, and the use of resources like nitrogen, P and K, and other stuff that are already in the soil. What I'm trying to say is that if we put a cover crop on the ground, even if it's just a little, it's going to use some of the nitrogen that otherwise might be leached. Okay, to your other question, can you please remind me again what we were talking about?
Yeah, we're talking about with biomass, like what levels of biomass do we need to have to actually get some types of benefits and, from ecological services and so forth.
Yeah, well, the first thing obviously is that the more biomass we produce, the better it's going to be, in terms of the benefits we are looking from the cover crops. Okay, I am talking here about corn and soybeans mostly. For conditions in Minnesota, I'm not really very concerned with, producing too much biomass. We have an environmental
Axel, maybe you want to turn your
our climate or weather
video off. I'm having difficulty hearing you.
And then we also, I'm going to try to stop my.
Stop your video.
I'm going to stop my video. Okay.
Okay.
Yeah.
There.
And the other thing is that one, I was saying that we have some limitations or some things that make us sure that we are not going to have too much biomass in Minnesota, and we would be fine. So one is the weather conditions or the climate, and the other is what we need to produce corn and soybeans with the way we do it. We are not going to plant corn and soybeans too late. I mean, the later I've been planting corn and soybeans is around the 20th of May, and by then we've been able to produce around 3,500 pounds of dry biomass of cover crops in Waseca. Less than 2,000 in Grand Rapids, around the middle for Lamberton. Believe it or not, site makes a difference.
Okay. And there's another question with biomass. How does biomass compare to plant density of the cover crop? Is there a difference between these variables for weed control? And I don't know, like from the weed control standpoint, necessarily I know people have just taken height measurements, for example, and correlated that to biomass. And that's been a pretty good standby. Taking stand counts can be very challenging. Cereal rye tillers. We've done that in research trials, and it is very challenging to get all the stand. And it's not always a uniform population, but there's a good correlation with height. I can't remember if it was 30 or 36 inch tall. Maybe it was 30-inch tall cereal rye correlated to about 4,000 pounds of biomass approximately. Wisconsin has some research on that, but I don't know if you have any other comments add to that, but that was just one of the questions that came up here. Let's see. Okay.
I guess that's it.
Okay. Well, I do have one, and Axel, I'm sorry, I'm going to direct this one probably to you because I know you've done work with interseeding, we have some questions about interseeding. Would
Sure.
that help? And they're wondering about early interseeding. They're saying like V6 to V7, but I know you've looked at different times. What effects have you seen on corn yield?
Okay.
Cereal rye
Yeah.
planted in July, but that's really not, you wouldn't really want to interseed cereal rye though either, right?
Well, yeah, that's a good question. First, we shouldn't be interseeding cereal rye early in the season because cereal rye is a winter crop, right? And it basically, because of that, among other things, is not going to perform as good as we would like to. That's one thing. The other, yes, I have done that. I have interseeded around at V0, which is at planting, at V2 before V6, and I did try V8 one year, didn't work because corn was already too tall and our equipment didn't handle very well, and we ended up just damaging too much corn. So V6, to me, at least for our conditions here in Lamberton, V6 is like the limit we should try to interseed. That's one thing. I guess they are asking for V6, V7, right? So at that point, if you interseed at V6, V7, from my experience, and I've done that more than once, is a waste of time and resources. It doesn't work very well, okay? And we have interseeded annual ryegrass, which is also a little bit controversial because it gets some issues with herbicides, resistance, those kind of things. But anyways, we've done that, and several things from here. One is annual rye. It has some things that are good. It's slightly more tolerant to shade than other cereals. That's one thing. Still, after it emerges, it stays like kind of dormant under the corn because the corn is going to quickly close canopy, and basically there is not much light coming through, and it grows very weak. By the time we harvest corn, that cereal rye, that annual ryegrass is like, it looks so terrible. And third, it will not affect the yield of corn at all because basically it doesn't grow too much. Okay, so that's what we've seen. We haven't published that, but we've seen that during several studies we have conducted here. Then we also have interseeded into corn and soybeans late in the season at R5, R6 corn and R7, R8 soybeans, more or less for soybeans when it's greening and starting to drop its leaves. And it works much better than interseeding early in the season. So that's the experience I've had so far with that.
Yep, I would, so I'd agree. And I know in your trial, for example, too, you went the extreme of seeding it at planting with annual ryegrass. The annual ryegrass grew great at that point, but the corn did not.
Yeah, you never do that. Yeah.
That's a bad idea.
Our best, we lost 60% of our corn yield. That was the best.
So very, very competitive. We have another question here. Oh, go ahead. Sure. Go ahead.
Do you mind if I chime in, Liz?
Sure.
Just that Axel said this, that it should not be winter cereal rye that's interseeded. And I think people have had that question, or I've talked to producers who've wondered that too, that if they plant it earlier, would they get more biomass? Because that's what we're always talking about, is that we need some biomass, and then would it overwinter and then have some spring growth? But really, in talking to some seed dealers and farmers, planting it too early, it really does peter out in the season, right? It is not meant for those warmer temperatures, as that's Axel correct. Said. But I think the thought process behind that is people wondering if they would get more biomass by planting it earlier, and that's just not what we're seeing.
Yes, thanks, Claire. Yeah, and one thing, like the early interseeding, it's not shade tolerant. Axel and I have worked on can prevent plant situations. We put cereal rye out there, and it was not, it gave you some cover, but planted in the middle of July, it was not a top choice for biomass. No. But that reminds me of a good plug. We should put a link to this in the chat too. The Midwest Cover Crop Council has a cover crop selection tool for anybody starting out with cover crops. It's a really nice resource, talks about kind of optimal windows, when to seed a cover crop, seeding rates, and so forth. So good thing to remind me of that. So I'm also looking here. We have a question about, have you looked at flying on with a drone. I guess I can say something. I know some of you saw this also. We tried this with our Cover Crop Academy. We tried a drone seeding at Lamberton, and unfortunately, we did not get any moisture after the drone seeding. So with the cover crop laying on the soil, we had a really poor take. Like, no, it was not good at all. So, I mean, that's just really key with anything. If you're broadcasting, if you can time it before a rain, that's good. But
that's one of the main issues. Yes.
Yeah,
And
it's
Liz, I would add when you're overseeding or aerial seeding like that, the amount of seed that you need to use to get a decent stand also adds significantly to the cost, as well as like a drone is going to cost you some money too. So it makes the economics of the whole cover crop system challenging as well for the potential for benefits.
right. Yeah, and that's, I don't know if you want to talk about one of the things of the seeding is like, people look at some complex mixes. Like Axel, again, your information was showing, hey, if we have cereal rye, we can go down to 30 pounds per acre, if it's drilled and seeded early enough and get decent biomass if we're terminating later, but so that helps us on the seed costs anyway. But some of these complex mixes, I don't know if you have any thoughts on that, if you've looked at some of these, but that can get very expensive too. I mean, there's good reason why we've used cereal rye as our go-to, just because it is easy to establish. You might think there's not much out there in the fall, but then spring we do get rain, and hey, there's cereal rye again, and it is more economical.
Do you want to go ahead, Jeff, or you want me to address that? Or both?
Go ahead.
Up to you. Yeah, okay. Well, yeah, we've done also mixes, different things here. When we work with mixes, we always mix with cereal rye, and the reason for that is because it's the only one that is going to overwinter, basically. So we have mixed with crimson clover, with forage radish, and with other radishes. And the thing with that, I guess Jeff mentioned that at the beginning of his presentation, is that by the time the season is gone, basically when the frost is established, basically those annual cover crops that we mix produce very little. It's so little that I also don't think there is any direct benefits to the environment with how much they produce. And Jeff nicely put that into play. So cereal rye is the cover crop so far to go for conditions in Minnesota because, as I said at the beginning, it's a very tough crop that overwinters under our conditions, and that's just one thing. The other thing with mixing cover crops is that not necessarily because you are mixing, you are going to get more biomass. I've seen very complex results from what we have done. Sometimes just the single or the monocropping cover crop does much better than the mixes, and I can speculate that it probably does that way because it has less competition. It just thrives, and in this case, I'm talking about cereal rye. So as compared to the mixes, cereal rye usually does, at the worst, it does as good as the mix of 3 cover crops. I have not done more than 3 mixes here in Minnesota.
Okay. Anything you want to add on that, Jeff? Or?
Yeah, I think Axel touched on a good thing. I think that mixes with cereal rye is probably a good option, and especially with this study that Axel's working on right now, showing some of these really low seeding rates of cereal rye, and then maybe adding 1 or 2 other cover crops they could be winter or annuals that are going to die from cold temperatures, but they could be in there, especially if there's early establishment, and then the low rate of cereal rye is still going to provide something in the spring.
Well, in this kind of time, we did get a question coming. The Midwest Cover Crop Council recommends oats after soybeans. So this would be you have corn and then seed oats. Well, excuse me, soybeans, then seed oats before corn to help prevent those issues of a green bridge, with insect pests and disease issues into corn, but is suggesting minimal benefit from fall planted annuals. So any experiences you want to share with oats planted in the fall?
Yeah, I think that, the aerial seeding following soybeans, I've seen that work in conventional tillage systems where the soil maybe has some loose, friable nature and you get a little good rain and you'll get some establishment. But if you're looking at a 2.0 or a 1.9 to a 2.2 soybean that's not probably going to be combine harvested until, October 5th through the 10th, that's not a lot of time for that annual to really do much, I don't think. And it will start growing as soon as the soybeans start to senesce, but there's just not much biomass produced, as Axel said. Now, if you're going to talk about using a much earlier soybean, where you maybe can harvest in Southwest Minnesota in the middle of September, that could be a different situation. But again, I don't think the soil health and water quality benefits really justify the practice. You need something in there that's going to overwinter, and maybe a blend of oats and cereal rye so that you at least get some product that overwinters would be the right choice.
Okay. Yeah, and I don't know if you have any comments on that, Axel.
No, I don't. I
Okay.
have not used that crop as a cover crop, actually.
Yeah, and I'll just say, I know because we helped put together that recipe, it's like early, easy entry points. We put that in there because it is a lower risk way to get into cover crops. You're providing cover in the fall, but you have to get timely termination in the spring. It's just an easier entry point for people. So that's why that has been put out there too through the Midwest Cover Crop Council, because oats are easy to establish in the fall, pretty easily to get some cover in the fall, but you're not going to get all the benefits of the spring. And we've got a number of questions soon. Just looking at the time, we've had some questions coming in about herbicides, and both of those guys wanted to hit that ball over to me. So I will just say a few things on that. We do have, I think in the chat, there's been resources put up that because, I put together a fact sheet looking at using herbicides and cover crops in a corn soybean system. That goes through a lot of the information on there. And there's a lot of nice resources on that. University of Wisconsin has put together a really nice summary of like rotational restrictions, because that's the thing. I mean, it's one thing if you're growing a cover crop just for soil health benefits, then you really can try whatever you want to do. But if you want to graze that cover crop, then you have to legally follow the rotational restrictions that are on the herbicide label. That's to protect the food and feed system. You don't want to get illegal levels of residues of herbicides into the food system. So that's why you have to follow those rotational restrictions. But if you're doing it for soil health, you can try different things. So there's some research on that. Check out that resource. There's also through the Take Action group, they have some really nice resources summarizing that. I wish we had a magic recipe to tell you what would work the best, but it all depends on what herbicide you're using, when you applied it, what cover crop you're doing, what's your soil type, what's the environment. I mean, there's just all these different things. There are lower risk herbicides, but then there's ones that have higher risk. So those resources are some nice resources for you.
Liz, I got a question for you kind of as a
Yep.
follow-up. So if you're considering grazing and these rotation restrictions because of herbicide choices are part of the factor, if you graze in the springtime, clearly that should not be an issue, correct? It would only be an issue if you're grazing in the fall because of the extra time, or how does that work? And then my experience is like, if you're going to seed cereal rye in the fall or late summer, usually the Cedaclor, Dual, things like that are all long gone if you put that on as a pre or early post. But it's some things like atrazine and some of the other post or broadleaf products that are more likely to be a problem. Would you agree with that comment?
Well, so your first comment, some of the rotation restrictions are 24 months or more, depending on, because some of them last very long. So you really need to look at the label to check, because you think, hey, I should be fine the next cropping season, and you may not be. So you really got to check. There's some products that are great pre-emergence herbicides, for example, but those rotation restrictions are very long to certain cover crops, and especially if you're using a complex mix. that hasn't maybe gone through all the rigorous testing, they're going to automatically default to the longest rotational restriction. And again, sometimes that's 18, 24 months. So you have to check the label on that. And your second part of the question, okay, if you're seeding, like let's say you put something in the spring, you're seeding like cereal rye in the fall. Cereal rye is one of the most tolerant cover crops. So usually, you should be pretty safe with that. If you're trying to interseed earlier in the spring, now that window between herbicide application and seeding the cover crop is a lot shorter, you're at higher risk of having issues. But yeah, but again, cereal rye has been one of our most tolerant. That's another thing why that's a nice fit too in a corn soybean system. Does that answer that okay?
Thank you.
All right. And let me see if we get some other ones here. Some of these we've kind of mentioned. Some people, let's see. Somebody who's talking about interseeding, trying it when the dropping leaves mulch the seed into germination. Yeah, just like interseeding late in the season. And it's kind of more of a comment, but maybe you guys want to comment on this too. Yeah, I think that interseeding late in the season, to me, that has more potential than the interseeding earlier. And I know that just talking with farmers too is trying to time it so you don't, like the leaves don't fall and then you have the seed on top, basically. So you get the seed it and then have the mulch. I think that would be.
I agree with you. I mean, interseeding is probably late in the season is probably a practice that could eventually work for our conditions. But as Jeff mentioned as well earlier, if you are going to interseed, you are going to probably use a little bit more seeds, which means it's going to be a little bit more expensive for you. But it works much better than just waiting until you harvest it and prepare the seed bed, those kind of things, because it's going to be too late. I've calculated, and I talked about that last year, from the time during the fall, we have more or less 45 days for the cover crop to grow under conditions that are going down in terms of quality. And during the springtime, we have as well more or less 45 days for the cover crop to grow, but under conditions that are getting better and better. That's why if we terminate too early, like end of April, as compared to terminating by the 20th of May, it means that we are basically getting the double and sometimes almost the triple of the amount of biomass just for waiting a little bit late in the season. The bottom line here is that if you want to use cover crops, we have to basically commit with it because there are several things that have to be taken into consideration. I mean, it's not just like I want to throw the seed there and see what happened. So it will affect my major crop if I don't really plan accordingly, and it has to do with the whole, production, system. So, but I guess it works, but it needs much more work. And one last thing before you cut me here, what we need actually is to have a breeding program for cover cropping in the state. So cover crops that are tailored to our conditions, and that would be great.
Yeah, I agree. And I know that we have, I'm going to kind of wrap this up. I know we have some other questions, but we haven't looked at all the different species out there, and actually you bring up an excellent point. And I think, Jeff, your stuff relates to this too, is, we know we have to optimize biomass to get the most benefits, or at least get enough biomass out there to have a benefit. How to do that is a challenge. And yeah, we've got limited resources right now to do that. How many corn hybrids are there, right? So, that's just some things to think about, but we're trying to get fine-tuning management to get the most benefit out of that. So again, I thank you both for participating today. Again, thanks to our sponsors, the Minnesota Soybean Research and Promotion Council, and Minnesota Corn Research and Promotion Council. And remember, next week, our session will be on how we adapt insects to breaking previously reliable management tools. But before we sign off too, I want to mention as well, we do have a survey that's going on from the crops team too, and we would appreciate people filling out that survey. We're just trying to see how, what different ways we can reach people on our programming and so forth. And there's a link, I believe that that is out in the chat. Thanks, Claire, for putting that out there. But again, thanks everybody for attending today. And thank you, Jeff and Axel, for sharing your information.
Glad to be here.
Thank you very much. Thank you. That was fun.